Okay. I will have a short overview about how S1Tiling was working before I CS refactored the software. What were the goals and that goals that have become features over the time, and then we have a more a dive into the kernel more exactly. We stay on the surface and just present how we can reuse S1Tiling kernel to do to orchestrate any processing based on OTB. So the original design, we were working by layer. First, we download everything. Then we calibrate everything. Then we cut all the borders. Then we auto-rectify, and then we assemble up to 2 auto-rectified files to produce the final product. At every step, we were working on all directories. We were doing a lot of search, a lot of production of files. And so there was a very important I/O usage. On HPC clusters, it could be very, very difficult because we are putting a lot of stress on the central file system. So it was a bit heavy on the processing time, and also from the start there was a very important feature that we were able to stop the processing and start it over, and we don't want to produce something that was already produced. The analysis was a bit rough in the sense that given the final products, we were able to deduce what we don't need to download. But still, when we add some intermediary files, we can reproduce them, we can reuse them, but not perfectly. So we try to see what we can do from this. But first, what Thierry wanted to achieve in the first place, because he had seen that he has a community of users interested in S1Tiling, so we need to industrialize the product. The first important part of the industrialization, is to improve the I/O usage, so to have to put less stress on the disks. Handling the start over after a stop was still an important feature. And efficiency, of course, but also other little features will have been added over the time, like the automatic writing of metadata in the GeoTIFF produced. Support of any data provider. At the time, only PEPS was supported. Now, thanks to EODAG, as Thierry said, we can support Copernicus data space, so we can support AS Safe, Creodias, and many others. And well, the installation has been simplified. We have Dockers built from scratch from the OTB binaries that run the files at the time, but now from the module tarbolts, and so on. So, and if it is interesting to have something easy to maintain, to evolve, and to reuse. So what were the critical points regarding the IOs? First, we know which files have been produced, so we don't need to scan the disk every time to say, okay, I need to do this again or not. And OTB, through the Python interface, can chain application and not write files at every step. The chaining of application can be done in memory. And this was really one of the core features of the new S1Tiling organization. A few other features have been added, but not the main important point for now. So we don't need to regenerate something that has already been done. That's the important point. So we don't need to glob even when we still need to glob when we start over to know, okay, what is the current state? But then we don't need to glob at each step because we know we have built a file, so we can start from this file. Some other feature also, in the case the processing has been interrupted because the job on the cluster has been terminated or because there is a crash somewhere, a partial file has been produced, but this file should not be reused when starting over because the file has not the right size, it's corrupted, and so it's done thanks a file extension. But well, anyway, so how is S1Tiling efficient? First, because we have improved the I/O usage, but also the processing are parallelized thanks to tasks. There are other features regarding the industrialization part. It's documented. We produce this GeoTIFF metadata. We have packet on PyP, where we have Dockers and so on. Thierry has already talked about them. So let's look into the kernel. So the two main objectives. The first objective was to use in-memory chaining of OTB applications. And as I'm a computer scientist, what I was thinking when doing this is, okay, I know a tool that is able to chain processing. It's Make. It's a tool used for compilation. And what does it need? It needs dependency that have been ordered on that has been a un tree topologique a topological ordering of the files of all the processings. Okay, how I do this? First, I need to scan all the inputs that I need. Okay, I have all my inputs in purple. In the first step, I will check from all these inputs what I'm able to generate, because I have a graph of all the applications in that can works. We can generate R1. From R1, I can generate O1, O2, and so on. From R2, we can generate O2, and we see that O1 needs the product from R1 and R2. And C1 need O1 and O2, C2 need O3 and O4. If a product is already on the disk, in the case of O1 or O2, I don't need R1 to product it. If I have C2, I don't need O3 and O4. So this means I can trim all the unrequired tasks, and in the end, I have this simplified graph of application to execute. So that was my starting point. In the end, I have a direct acyclic graph of all the tasks that can give to Dask, and Dask will take over from this point. If I look at two typical pipelines, the first pipeline, given my inputs, there are files from Sentinel-1 SAR files, I will prepare them for the auto rectification. This means we have auto-ready files. The files that is auto-ready has been cut and calibrated. Cut and calibrations are two OTB applications. But I don't have any files in the middle. I directly produce this one for the original product. And then, given one target S2 tile, Sentinel-2 tile, I will auto-rectify my auto-ready product for this tile. Another file can be auto-rectified for one tile and for another tile. And then I will concatenate two products that have been auto-rectified for one tile and they are contiguous in time. Okay? And this will give my product. This is a simple and straightforward chaining of application. But this is the original chaining of application. Now, S1Tiling support more complex chainings. Here we can see that for each processing, we have only one kind of source of input. For each processing, we have only one kind of consumer. In this new processing, it's not the same. First, we still have the Sentinel-1 products, but we have also other kind of inputs. We have precise orbit files here in the blue circle. And sometimes some processing, like the one that produce the ECEF coordinates on the ground end of the satellite, needs two kinds of inputs. Some other processing, actually the same, produce inputs that will be reused by two other processing. So we're starting to have pipelines that are more complex than the original one, and they are still supported. Now, the question is, how do we express that? So first we have steps. A step is a processing. A processing is the auto-rectification, the calibration, the cut of the border, and so on. They're organized in steps, and those steps are instantiated through step factories. Then they are sequenced and put in a pipeline. The pipeline takes a file, produce a file. If I have several steps in the pipeline, this means those steps won't produce a file at each time they are executed. If I have several OTB applications, I will use in-memory chaining. And the pipeline will chain OTB application in memory. And also need something else. I need to say, okay, my system have inputs. These inputs has been abstracted through first step factories. And through that, I can download automatically Sentinel-1 products. I can download automatically precise orbit files, or I can inject metadata, meta information about the S2 tile I'm working on. And now I have a kernel that is completely independent of what is a Sentinel-1 file, of what Sentinel-1 does. But S1Tiling does. But S1Tiling uses this kernel. Okay. Let's say I'm a user that want to reuse Sentinel-1 kernel. This is a rough simplification about how I do it. First, I instantiate a pipeline description sequence. This means this is an object where I will register pipeline. And I have also need to register all the inputs. For instance, my Sentinel-1 product will be registered through a dedicated factory, and they can be accessed through the metadata base name. And then, okay, I have a calibration sequence which correspond to all the OTB applications that will be sequenced to produce the auto-ready file. I need to extract some metadata, analyze the borders. They're not OTB application, but steps that do some analysis on the files. And then I calibrate. I fix the denoising if denoising need to be fixed, and I cut borders. From this pipeline, I can chain another simple pipeline that just does the octo rectification. And then I chain the concatenation. Each pipeline consumes files, produce files. And in the middle, I'm chaining OTB applications or other applications. This is a simple case. In the more complex case, but this time, I register two other kinds of inputs. And these inputs are not Sentinel-1 products. One is the processor bit file. The other is something that can be used to extract information about the tile I want to work on. Okay? And then I have my pipelines. The first pipeline is just an agglomerate DAME. This is not an OTB application. This is a JDAL process. At first, it was an external JDAL executable. Now I'm using Python API of JDAL to produce the agglomerated DAME and to produce the VRT. From the VRT, but I know I will give a name to this input, to this pipeline, because thanks to this name, I say, okay, the VRT can be used in the next pipeline, and we will give a meta name to this input to reuse it and to parameterize the step factory. The first step factory are not that complex. Where it becomes interesting is in the third one, where I'm producing ECEF coordinates. Here we can see that I'm consuming two inputs. I'm consuming inputs that come from the processor bit file I've produced, and I'm consuming inputs that came from the previous step. It seems we don't see here, but internally, the pipeline, they are reusing an output at several places. This can be expressed. This does not appear here, but it can be expressed. I could have reused the DEM VRT in another pipeline. It's not the case here, but it could have been done. Okay. This is how I describe the processing I want to do. Now, if I want to use it in my own Python application, I will have to register the parameters for the input factories. Because, okay, I want to download Sentinel-1 products, but how do I download them? But I pass the EODAG parameter. I pass another object that centralizes the analysis and the downloading of all the Sentinel-1 product, given the time range of the request, given the polarity requested, and so on. And then I define a Dask context, and in this Dask context, I will process over all my tiles. Okay, processing over a tile is very Sentinel-1 specific. It's very S1Tiling specific, but internally, it's simple. I'll start, sorry for the colors, I'm starting by creating all the directory that are required for the product generation. Then I'll register extra parameter for my input factory. This is where I'll register the current tile name that will be reused. And I execute on the pipeline object generated before. I execute something called generate tasks. This is the part that generates the direct acyclic graph of tasks that can just pass to Dask. I'm using Dask, but we can simply use the new processing method from Python 3.9. I'm using Dask. Anyway, in the end, I obtain I'm obtaining objects that are outcomes. For people that know C++ stood expected or boost outcome, this is the same idea. This is a monadic object that can store either a successful result or an exception. Thanks to that, I can list at the end, okay, here is everything that obtained, and I have okay, where I have successfully produced this product, or sorry, I have an error on the production of this product because some execution could not succeed, or because I'm missing some input that I could not download, and so on. And I have something that can be reused. This means that the kernel from S1Tiling can be seen as a Python orchestrator dedicated to OTB application. It could be used for other things, but where it's interesting is because we can chain OTB application in memory automatically. That's really the core point of S1Tiling kernel. So just in order to summarize how it works, we will have domain-aware step factories. This could be OTB application. This could be Python function, external processes. We will sequence all these step factories in a pipeline description. If I have multiple step factories that are OTB application, they will be chained in memory automatically. And then I'll register all the pipeline description in the pipeline description sequence that is the main object. And then the kernel will take care of searching all the possible inputs and of generating the direct acyclic graph of tasks that can be used by Dask. Concrete and specialized step factory is usually configured from configuration object that is specific to the application. Thierry, I've shown you the configuration file that is used by S1Tiling for saying, okay, I will use a precision of 10 meters, for example. This can be passed through this configuration object. And then internally, it will really work on input metadata to determine, okay, this is the name of the next file that I will produce. These are the execution parameters I will use, and also to determine the GeoTIFF metadata I will write. If I want to define the calibration step factory, but I first inherit from the S1Tiling dedicated class, then in the constructor, I will register the typical file name that is produced. The file name that is produced will use those metadata. The root name is automatically generated, but the calibration type will be injected in a function. It is a hook that will is called automatically. Okay, and other information are stored. We also save the name of the description for the GeoTIFF metadata. And this use calibration type flying unit flying unit information that are automatically obtained from the original Sentinel-1 product. So how I generate the file names. And I have another hook where I'll register all the metadata that I want to write as GeoTIFF metadata. And finally, there is this parameter function that define, okay, when I call the OTB application, I will inject this list of OTB parameters. Simple step factory are as simple as that to define. Not all step factory are simple as that, unfortunately. If we dive a little bit more internally, factories, what does a factory do? A factory instantiates object. So yes, I have step factories, but the step factory instantiates generic steps, and these are the ones that would be sequenced by task. But nothing of this is of your concern unless you want to work with me on S1Tiling. So, what next? But first, a new chain in S1Tiling are currently under development. The local incident angle correction is being refactored and will arrive in S1Tiling 1.2. RTC correction has been written as well, and it will also arrive in S1Tiling 1.2 as soon as we have finished our process of freeing some internal development for open source. It's just legal stuff. And another important chain is coming is about producing maps of incidence angle on the geoid directly. This is pure S1Tiling on this point. We have been asked a question about SLC. Yes, we will have SLC. But regarding SLC, it would be another product. It won't be S1Tiling, it would be something, the internal name so far is SLC time series. We will reuse S1Tiling kernel, but we don't produce images